start. How was the exam? Pretty good. Nice. So for exam 2, I think the exam 2 will be started from like week 4, right? So you guys need to understand standardization, maybe basically property of the normal distribution, and then maybe Professor will move on to the estimate of the population rate when we have a sampling data, sampling distribution. And in this, like during the whole course, I think the understanding of distribution of the sample mean will be really important. Okay, and then what I'm going to do, I'm going to explain. Actually, I actually explained part of that last week, and I'm gonna do the exact same thing with the different simulator. I think this simulator is better than mine. So if you go to the week 6, you can see the link to that simulator. If you click that, you can see this website. This is for our textbook website, and I want you to click the begin button at the top of the page. If you click that button, we have these 4 plots, but we can just ignore the last one. Now, so we have 3 plots. Okay? These 2, for now we have blank, but we're gonna have some boxes there. And let me explain the context of this simulation. So we have a population distribution at the top of the website. That black distribution represents our population distribution. So let's say we assume that the heights of the students in U of Iowa follows the normal distribution, and its mean is 16 now, and then the standard deviation is 5. So that distribution does not change, right? That's a fixed distribution. And what I'm gonna do, to figure out some information about the population distribution, I will go to the street, and then maybe I can grab 5 students and then ask their height. And if I click this animated button, it will do it. So I'll go to the street, I meet these 5 guys, and then I ask their heights. One maybe saying like this is 0, 32, maybe 16. Maybe he said that his height is 8. Okay? And then I have one guy whose height is around 16, and then this one is the largest one that I met among these 5. It will be like maybe 20, around 20. But what I did, I'm not using just each observation. What I did is I summed them up and then divide by 5, so that I got 1 sample mean. Okay? And we want to focus on this 1 black box, not 5 black boxes. And blue box. And what we want to do, I want to figure out the distribution of this blue box. Okay? So I want to do the same procedure. So this time I got 5 sample, so 5 students, different student, right? Before, and 2 of them has the same height. And then I took the same sample average, and then I got like 1 more blue dot there, blue box there. And if I do it again, I'm gonna get another blue box. And I want to accelerate the whole process. So if I click 5 here, it means I repeat the same procedure 5 times. Okay? So this is the empirical distribution, empirical histogram of that my sample mean. Okay? And there are 8 observations there. And if I click the 5, and then if I make the, I like this clicking sound so fast. I have 100 observation, blue boxes, and then the histogram looks like this, and then we can see that distribution looks like bell curve, right? Okay. And if I hit this one, hit normal, it looks like normal distribution, but it's not that close. Right? We have like some space there. But what if I do 10,000 times? Okay, so this is the histogram, and then I use the 10,103 blue boxes, right? But you should know, like, each boxes consists of 5 black boxes, right? And now we have like really beautiful bell shape, and it looks like it synchronized with the theoretical normal distribution. So I say, hey, this blue distribution actually follows the normal distribution. Okay? And then what is the fact that you can see by comparing the blue distribution and the black distribution? Can you tell me what is the difference between these two? Or maybe can you see what is the common thing? Yep.
Well, the standard deviation is less.
Less. Which one is less?
The second one.
Yeah. Blue one is less. Has less standard deviation than black distribution. In other words, we have like narrower distribution in blue, right? It has a narrower than red one. Is there anything that you can see? What about mean? Same, right? So to recap, we have blue distribution. It follows the normal distribution, and whose mean is the same as the population mean, but its standard deviation is become narrower. Become less than the population standard deviation. Okay? So just keep in mind this shape of the blue distribution now, and I want to change this 5 into maybe 20. Okay? And then I'm gonna do like 5, 5, 5, and then I'll just do 10,000 times. Okay? What is the difference between this blue distribution and the previous blue distribution? More smaller, right? So before we have more wider blue distribution here, but now it become more narrower, right? And what is the difference between these two? I pick 20 students, right? Each time I grab 20 students and then take the sample mean. Okay? That the sample size makes the affects to the spreadness of the blue distribution. Okay? So if I choose more larger sample, like 25, it will be more narrower than the 20. Okay? So compared to like maybe 2, this one is like large, but if I go with the 20, still normal, but like really narrow, right? Can you tell me what is the so we knows that this follows a normal distribution, and then mean will be the same, but standard deviation will be different. But can you tell me what is the relationship between like 1.60, which is the standard deviation, is the of the blue distribution, and 5, which is our population standard deviation? Yep.
The blue graph is based on means of different samples, and the means will always be closer to the population mean, usually than an individual. So that means that all of your data values are going to be closer to the mean.
So that's why we have like more narrower distribution here. But can you tell me the relationship between like this narrowness, like which is like 1.6, we have specific number here, with the 5, like population standard deviation? Yep.
Or maybe what the means, even though it is a sensitive measure, like you're still going to get relatively similar values each time, so there's less variability in what value you're going to get, so the standard deviation will be less.
How can I say? Yep.
Is it like? Wait, I don't know. Because if you square the 1.5 or like what a
Square the
1.6,
1.5.
and then you get like 2.5 ish, and then take that times 2. I don't know. I'm messing up.
So statistician actually found the relationship between this number and that number using n here and like it's a population standard deviation 5. So if you if we have information about the standard deviation, so in this case, let's say, let me just write down the situation using statistical notation. So we have population distribution. So let's say I say X is the random students' heights in U of Iowa, and I know that that follows the normal distribution, and whose mean is 16, and the standard deviation is 5. So that X follows the normal distribution 16.5, right? And then now I want to put bar there. So X bar is the like sample mean of this case. I choose 10 students each time. So this X bar represents the random variable of the sample mean. So each time I pick the 10 students, I will get different number, right? Different blue boxes. So we can see this one, distribution of this one also follows the normal distribution because we have nice bell curve there. And what we have discussed before, the mean of this blue bar, same with the population mean, 16, right? But we have noticed that this is narrower than the black one. So I don't want to write it down 5 there, but I can calculate that standard deviation using by dividing by square root of my sample size. Okay, so if I calculate that, that is the like 5 is my sample population standard deviation, and then I got 10 as my sample size, so 1.58, and we have what is that? 1.6, which is really close to the 1.58, right? So this thing happens with a different n. So we have, what if every time I pick the 20 students and then take the sample mean, then distribution of that sample mean will follow the normal distribution. Same with the population mean 16, but this 1.13, the standard deviation of this one can be calculated by 5 divided by 20. 20, which is 1.118, then I can say 1.118. Yeah, 1.118 is really close to 1.12. Does it make sense? So, to recap, I can where's my I can say this. If my population distribution follows the normal distribution mu sigma, I can say my distribution of the sample mean will follow the same normal distribution, same mean, but with the standard deviation sigma over square root of n. Okay? So now we know that that thing happens when the population distribution is the normal. Okay? Let's just switch my population distribution with the skewed distribution. So we have skewed distribution, skewed to the right actually, and I want to pick 5, and I want to do the same thing. So I will pick, let's just go with the 10 then. Okay. So since the distribution is skewed to the right, which means I'm gonna have more observation here than this part, because basically it says that I have higher chance to see observation around here than this one, right? So I got more observation here than this part, and my sample mean is that blue box. And if I click the animated button again, I will get another sample mean, right? And then if I do it again, I'll get another one, right? So we have 3, and it will be 5, like this. And my question is, what is the, so if I click this 10,000 button, I will see the true distribution of the blue boxes, right? Do you think it will follow this population distribution? Or do you have any other idea of the distribution of the blue boxes? What do you think of the future shape of the blue distribution? We're gonna see if I click this 10,000 button, but before that, I want you guys to guess the shape of the distribution. How many of you think it will be skewed to the right? Skewed to the right. How many of you think it will be different distribution? Which distribution? Normal? Okay. So it will be normal. Okay. So this is the maybe interesting thing to see. Even if we don't have like population distribution as a normal distribution, when I take the sample and then take the sample mean, the distribution of the sample mean will follow the normal distribution, always. Okay? And what is the mean of this distribution? It will be mean of the population distribution. So we have 8 for population mean. So location center of this distribution will be 8 also. And what is the standard deviation of this one? It will be sigma over square root of 10. So we have sigma is 6.22. So 6.22 divided by square root of n. 6.22 divided by square root of 10 will be 1.96. We have 1.98. Okay. So this is the maybe power of the statistics. Even if it does not follow. I mean, the population distribution does not follow the normal distribution. We can guarantee if we have like larger sample, the distribution of that sample mean will follow the normal. Okay. So let me just change a little bit about our context. Okay. So this is the maybe closer to our real life situation. I know the population distribution, but you guys don't know, right? I am only, and it will be I don't know, weird distribution. You guys don't, you guys have no idea about the information about the population distribution. But if I can give you some information about the distribution of the sample mean, you can actually guess, or you can actually have some information about the population distribution. Can you tell me what is the mean of the population distribution?
Is it 15.97?
15.97. Yeah. What is the standard deviation of the population mean? A population distribution. Can you guess? What is the population standard deviation? We have 3.05. How can you calculate the population standard deviation?
Is it 3.05 over root 10?
So in here we have two numbers. If you map this value, which one? Upper one or this one is the lower one. So we have now we have 3.05, right? But we know that this number can be calculated by, I don't know what is the standard population standard deviation, but if I divide by this one with the sample, which is 10, I will get this one, right? So what is the standard population standard deviation? It will be 3.05 multiplied by square root of n, right? Okay, does it make sense? So if I do 3.05 multiplied by square root of 10, 9.64, so 9.65. Okay, and then we have calculated the population standard deviation. Can you guess what is the shape of the population distribution? It will be L shape or skewed to the right, skewed to the left, or no idea. Answer will be no idea, because we have seen that when we have a nice bell shape in our population, we will get this bell shape, nice bell shape. But when our population distribution is skewed to the right, we will also have this bell shape. Okay, and actual population distribution looks like this. Okay, this is just not like totally different distribution, right? It's just like uniform. Okay? But even if the population distribution follows the uniform distribution, like which is far from the normal distribution, we can say if I take the sample and then take the sample mean, the distribution of the sample mean will be normal. Okay, and we can see the population standard deviation is 9.52, which is really similar to 9.64. Okay, so now I switch context to our real life. Okay? So again, we don't have any information about the population mean, but let me just check. But I will give you, either because I know the information about the population distribution. We don't know what is the population distribution, right? And then we don't know about the mean, right? But I will give you one information about the population standard deviation. It will be 4.74. Okay. And then, so, which means you guys want to figure out the true mean of the heights in U of I students. And what you guys do, just go to the street, grab the 20 students, ask their height, and then this is their height, and then you calculate the sample mean of these 25 students. Can you estimate the mean of the population? This is exactly the same in our real life survey, right? You want to figure out the mean of the population distribution. So you want to figure out what is the true average of the height in U of I students, and you just go to the street, ask 20 people's height, and then calculate the sample mean, done. We are not repeating anything because if you want to do repeat, you need to spend your time, and maybe you should give some gift card or something, so you should spend your money too. So just what you can do, just take the one sample, sample size 25, and then take the average, done, right? So you have only one point, like blue dot. Can you estimate the population mean?
That's what the same. I mean, I can not be very accurate for 25.
Mhm.
Should it be the same value?
Based on what Alex said, so since I got this point, so it will be like, I don't know, this will be 16, maybe 14, around 14. Can I say the population distribution, mean of the population distribution is 14? Do you guys buy it? No? Then my follow-up question, even if I see this one, can I say, hey, I think the population mean will be around here? Compare these two, what did you choose? So this one and that one. Which one will be more likely to be our population mean?
Do you mean given we only have the 1 point, or if we
Only
choose
1
it?
point.
Well, that's our best guess.
Yeah,
but
this is our best guess. But somebody, like even if we have like this one, maybe me, I don't trust this one. Maybe I can just estimate my population mean will be around here, like around 30, right? But compared to my opinion, and then like somebody want to use, hey, since I got observation in here, I can use this one as my estimate of the population mean, right? Compare these two, which one will be more reasonable person? It will be the one that choose this one, and why? Yep.
It's like the only true data that we actually have.
Uh-huh. But is there any connection between the thing that we have seen before? Like when you think about if we do this thing multiple times, is there any chance that I can get a blue dot here?
Just like
Just think about the situation. We have like black distribution, and then blue distribution has some characteristic, right? It has more narrower distribution, right? So when you imagine the distribution of this blue dot, it will be narrower, right? So can you say, hey, maybe when I do multiple times of this process, is there any chance that I can get blue boxes around this one here, 30, and here?
It's really unlikely.
Unlikely. Unlikely. Why? Because I know that this one follows the normal distribution, right? And then I don't know what is the mu, but distribution of this one will be the same, right? I don't know. It will be distributed around the real mean. And then what is the standard deviation? Standard deviation will be 4.74 divided by my sample size, 25, right? So if I calculate the standard deviation of this blue dot, it will be 4.74 divide by 25 is just 5. So 0.9, 0.94. Okay. So what does that mean? I don't know the population mean, but it will be distributed around this one. And then standard deviation is 0.94, which means if I take the two standard deviation range from its mean, it will capture the 95% data, right? I mean, like 95% of the blue boxes. So, like since maybe it's each distance between each dot, not dot, right? Like each this one, like I don't know, mark between the marks will be the 1. Then two standard deviation range will be like this, and then this range will capture the 95% of the blue boxes. So you guys and including me, we never gonna see the blue boxes around here because I know that the standard deviation of the blue boxes is really small. Does it make sense? So what I'm gonna do, I wanna use this one. So maybe this one is like 10, so 14. I can say, hey, if I take the two standard deviation from that sample observation, if I take 2 multiplied by 0.94, which is like population standard deviation divided by my sample size, and then 14 minus 2 multiplied by this like standard deviation of the blue boxes. This range, like this range will capture the 95%. And that range will capture the population mean with a probability of 95%. Okay? Does it make sense? And we call this range as a confidence interval for population mean. Okay? Does it make sense? Okay? And if I do that, it will be really narrow. Okay? So it will be reasonable to say, hey, I want to use that sample as an estimate of my population mean. Okay? And then our actual distribution looks like that. So the mean of the population distribution was 12.84, and since my actually calculated standard deviation is 1.9, which is almost 1, so if I subtract the 2 from 14, my confidence range captured the population. Does it make sense? Okay. So you're gonna do a lot of this process in exam 2 or in your final. Okay. So this is the core, and this is really important to understand when you study statistics. Okay. All right. I want to move on to the SAS program. So today, or maybe if I recap, even if we don't know what is the population distribution, our sample mean follows the normal distribution, mu and sigma over square root of. And for SAS section, I want you guys to know about the tabular procedure, which allows us to make a continuous table. Basically, we're gonna use this data set, but I'm gonna go to just data set itself, where so this is our data looks like. We have two columns. One is the score, and then the second one is the group. Okay? So each person. So first person belongs to group 1, and then her score is 156. Okay? And second person, her score was 119, and she belongs to group 1 also. And this guy, maybe, his score is 144, and then he belongs to the second group. So we have 3 groups, and then each person has a score. And what I want to do is I want to draw the summary table, which shows us the some statistics for each group. Okay, so this is what I want to use. You know what? I put all of my codes in my my website. So for now, maybe you can just watch what I'm doing here. When you guys see these 5 lines, this is the code with what we have seen before. So we declare the URL for the data set, and then we declare the title of our data set and ask SAS to go there URL and then grab the information and save to the this data set. And we just let SAS know about that we're gonna use 2 variables. First name of the variable is the score, and the second one represents the group. Okay? So if I submit this one and then run, I will get just data. So I can use print data is equal to run. We can see like 2 column. First has a score, and then the second column has a 1, 2, 3, right? Group number. But the situation is like this. I don't want to use number for each group, because let's say this data is actually just some experimental about the patient. So first group has a some treatment like teaching and a training, and second group received only teaching, and third group received none of them. Okay? So instead of writing 1, 2, 3, I want to use this teaching and training for group 1, teaching for group 2, and neither for group 3. Okay? So to do that, what I did is just declare the pre-format for my future variable group. Okay? And then the name of my format is GRP FMT, group format, stand for group format. And that format tells SAS whenever it has a 1, just replace that value with that teaching and training. And whenever it has a number 2, it will be please replace this number into the teaching, and 3 for neither. Okay? And then once I define this format, submit, and then when I load the data from that URL, I can put this format option, the last one. So, hey, I want to use 2 variables whose name is score and group, but when you load the data for group variable, please use format name grp fmt, which I defined before. Okay? And if I run that, and then check the data, I'll get teaching and training for group 1, teaching for group 2, and neither for group 3. Okay? And now, what I want to do, I want to calculate some statistics per each group. Okay? So I can do it using proc tablet procedure. So proc tablet, I'm going to use Boolean data and declare group as my class, which is like left hand side. You're going to see the result, and then variable. I want to use score for my variable in the table, and the table has two values. And if I cut this one, we can see the basic form of the table that proc tablet will give us. So we have group in the left hand side, first column. So teaching and training, teaching, neither. We have 3 group pair, and then we have a score, and basically that table tells us the summation of the score per each group. So the summation of the total score of the people who belongs to the first group is 1,395. Okay? But if I could star and n means standard STD-DV, which stands for standard deviation, I ask SAS to calculate these 3 per each group. Okay? So if I run that, now I have 3 groups, and it has observation per each group and a mean and standard deviation for each group. So we have observation, mean, standard deviation for group 1 through 3. Okay. Does it make sense? Okay. And there are so many options that you can choose for this proc tablet. These are the options that you can use. So we already use n and STD and what is that, mean there, right? And if I choose other option, it will calculate that statistics. We can choose descriptive statistics and quantile statistics too. So by using this one, actually, you can make a contingency table which will give you the 5-number summary per each group. Okay. Now, since we have already running out of time, I'm gonna write it down my code for doing it. So this is the place where I should put my statistics that I need. So what I want to do, 5-number summary should be mean, Q1, and median, and Q3 max. Right? So if I submit and then run, I'll get 5-number summary per each group. Okay, does it make sense? And I also put another example for the billion data set actually, and then it has some code for converting the categorical variable into your own. We code this as a coding. So I put another code there, SAS code there. You can see if you need when you do your homework. Okay. Okay, I'm done today. You guys can go. Hope you have a great evening. If you have any question, you can just stop by my office during the office hour, or you can just shoot me an email in advance if you want to meet me.